Good afternoon. Well, I welcome you all to VTU EduSat program. In today's lecture on analog electronics, we will be dealing with MOSFETs. So, objectives of today's lecture are students will be able to understand the concept of MOSFET, in that they will be knowing their classification, what are its construction, operation and characteristics. By the end of this lecture, students would be able to compare the operation of MOSFET with JFET. Now, to start with, what is a MOSFET? MOSFET is a type of field effect transistor, that is, it is a unipolar transistor and voltage controlled device in which the majority charge carriers flow in the channel. The conductivity of the device depends on the channel width. So, if the width of the channel is controlled by an electrode, by applying an voltage to an electrode called gate, then the conductivity of the device can be controlled. So, MOSFETs have wide range of applications. MOSFETs are very useful in high speed switching circuits. The reason being, the conduction in MOSFET takes place only through one type of charge carriers. The minority charge carrier storage is not there, owing to which it results in low power consumption as well as the speed, switching speed will be on the higher side. Hence, they are most widely used in integrated circuits. Now, let us look up what are the classification of MOSFET. MOSFETs are classified into two types. The first type is called depletion mode MOSFET. The second type is called enhancement mode MOSFET. The depletion type devices can be further categorized into N-channel depletion mode MOSFET and P-channel depletion mode MOSFET. On the other hand, enhancement mode MOSFETs are further classified into N-channel enhancement type MOSFET and P-channel enhancement type MOSFET. Now, let us take up the structure of depletion mode MOSFET. The structure of depletion mode MOSFET is as shown here. The starting material is a thin silicon slab which is doped with acceptor impurity, thereby resulting in a p-type semiconductor. The resulting p-type semiconductor is called a p-type substrate. Into this p-type substrate, the other two regions, that is source and the drain, are to be formed. In order to form source and drain regions, two heavily doped N-type regions are diffused into the p-type substrate. So, one region, one N-type region will be called source, other N-type region will be called drain. Now, the entire P substrate, entire device will be coated with silicon dioxide material. Silicon dioxide is grown on the entire p-type substrate and this serves as a good insulator. So, a window is created here to establish the contact with the other regions to the external terminal. So, via this window, metal contacts are metal is deposited and a external terminal is connected to form source and the drain and gate terminal. So, in fact, channel is also created even before the metallization process, that is laying of metal is been done. So, this channel is in fact implanted using a process called ion implantation. The difference between JFET and the depletion mode MOSFET structure lies in the use of silicon dioxide. So, this silicon dioxide is a very good insulator. This is one of the property of using silicon dioxide, and moreover this silicon dioxide isolates the gate from the action of the channel. So, so that the main important characteristics of the MOSFET or FET as such, that is gate current is equal to 0 is satisfied. Another important aspect why silicon dioxide is used is it sets up opposite electric fields when an external voltage is applied. So, external voltages will be applied to the gate terminal or and between drain and source terminal. So, due to the action of these two electric fields, due to the application of these two external voltages, two opposing electric fields are created, induced across the device. So, this property is one important property of silicon dioxide. Another aspect is that since silicon dioxide is used to insulate the gate from the action of the device, the input impedance of the MOSFET are higher than that of the JFETs. So, this N channel which is permanently existing owing to the which is existing obviously the conduction of the operation of this particular device can be understood by considering various potentials applied to between gate and source and drain and source. Now, let us take up the symbols of depletion mode MOSFET. So, the first symbol is the P channel. In P channel devices, as you can observe here, there is one additional terminal in MOSFETs called substrate terminal. Usually this substrate will be connected to the source, that is source and the substrate must be held at the same potential. If the external substrate connection is available, then this will be treated as the fourth lead of the MOSFET. So, the four terminals of the MOSFET are gate, drain, source and substrate. Suppose substrate connection is already available or internal substrate connection is already made, then the symbol of the MOSFET is as shown here. Look at the arrow mark. This arrow mark indicates the source is being connected to this substrate connection. Now, observe the difference between or the distance between the gate and the channel. So, this is actually this straight line represent channel, this node represent the metal gate. So, the distance between channel and the metal gate indicates that their gate is completely isolated from the channel. That means to say that there exists a silicon dioxide layer between gate and the channel. Now, the device is this portion is the symbol of N channel. The difference lies in the direction of the arrow mark.